Hi, my name is John, and welcome to another edition of Statistics Quest. I'm going to talk to you today about Bayes' theorem, again in conjunction with Tom Brady's career. So it's kind of a continuation of what we talked about last time, but I'm going to actually have two more parts. One is kind of an elaboration on what we discussed the first time, and the second one is going to be with numbers involved. Okay, but I'm going to kind of lay out the structure of what I'm going to do. Okay, so the thing about, and the reason that I want to emphasize Bayes' theorem with Tom Brady and football in particular is that football is much harder to quantify than baseball is. For example, in baseball, somebody could hit 40 home runs and you have a pretty good idea of what that meant, what you had to do. You know, you might have a couple inside the park home runs. You might have had a couple home runs that, you know, were hit from poor pitches. But by and large, somebody that hits 40 home runs, let's say in an average park, we know what they did. We can kind of get a handle on that, and we can weigh it, so to speak. Even if it was in Coors Field, where numbers are inflated, we could index by the park, what's called a park factor adjustment, and we can get a sense of that. So maybe 40 home runs at Coors Field translates to 28 home runs in a neutral park. So we can still get a concrete sense of what it means in baseball, because baseball is just much more concrete. It's one-on-one, and we know how to translate what that means. Football, you could have a quarterback, maybe in a particular game, let's say, or even over the course of a season, but let's say in a game, they passed for 350 yards, 3 touchdowns, no interceptions. You're going to say, oh, he had a really good game. Probably had a good game, but he might have hit wide open receivers. He might have missed those receivers by 5 yards and they had to come back to the ball, but the defender had slipped. Might have had all day to throw. So all kind of new team factors in football that don't factor into baseball. And so that's why I want to use Bayes' theorem with football, in particular Tom Brady, because he's had obviously a very interesting career, a great career, but there is a caveat that I mentioned last time, and that is that coming out of college, he wasn't sought after. He was a late sixth-round pick, actually the 199th pick overall. So there's something about that caveat in conjunction with Bayes' theorem, which we'll get to more in the second episode, that kind of casts a little bit of doubt as to where he should rank all time. Okay, so just to further illustrate, okay, we assess a player on his career. And this is very important to point out. Even in football, right? I mean, if somebody, has, they got 20 years and they have so many touchdowns and they have so many interceptions, etc., we want to assess the player on what he did, but here's the kind of the caveat that I'm mentioning. What did he do? What does 350 lifetime touchdowns and 110 interceptions really mean? 350 home runs, we know what that means. 350 touchdowns, we don't really know what that means because context is important. So that's it almost sounds like, and even as I'm saying it, that it's a little bit contradictory. On the one hand, we do assess a player on his career. But on the other hand, in football, since we don't quite know what to make of his career with the numbers, because there's, it's very cloudy, we're going to use Bayes' theorem, and as we'll see in the next episode, we'll make projections, and that will be kind of a proxy for his career, okay? And I'm going to leave it at that for now. Next time, we'll get into more number crunching, And we'll see you next time on Statistics Quest. Thank you.